All right, folks. So we're going to do a quick little topographic maps review and a couple new things. Um, so we've done maps like this before with isotherms and isobars. We're going to do contour maps with elevation now. So first thing I need you to look at when you encounter a map like this one right here is the contour interval if it's given to you. We're working with 2 meters, therefore every line is going to be a 2 meter change from the one next to it. The lines given to us, we got 42 and 48. Therefore, if we're going to go up from 42 or down on this paper, it's going to be 44, 46, and then as we work to our next line, it's going to be 48. Moving down the map, we got 50, and then right by D is 52. So when it's asking which location is likely to have an elevation of 45 meters, we're going to pick the one right between 44 and 46, which is B. Bingo, giving us our correct answer. So here is another map that you might see in the future. What I'd like you to do is to figure out the contour interval. All right, great. Let's see how we did. How I would go about this, take what the map is giving you. We're given a bunch of numbers on lines. I'm going to pick out this 780. The next line is 800. The next line is 820. Each line is going to go up by 20 kilometers. So my apologies, it is actually meters on there. So each change, we're going up by 20. Therefore, our contour interval is 20 meters. Okay, same picture. What's going on with point X? It's in the middle of a circle. So what happens if I go to the side of point X, I'm going up from 780 past the 820. Then if I go on the other side of X, I'm going up from 780 again, this 780, all the way up to X past that 820. So all X is the top of a hill. Hills, they are circles or ovals on your map. Always will be that way. The only way it can be different is if it has little sutures or little lines coming off of it. That's showing that is the opposite of a hill. It is a little pit or a depression. It's going down rather than up. So X right here, all it is the top of the hill. So here's going to be a practice question for us. What could the elevation of point X be? Give it a try and see what you can do. Okay, so we're looking for point X. We know our contour interval is 20. Therefore, if we had another line squeezed in that circle, it would be 840. But we don't. So we are looking for an elevation somewhere that's lower than 840, but bigger than 820 since it's within the 820 circle. So out of all our options, 826 is the best. If we had 841, we would need that 840 contour line. Same deal with 850. Since we don't have the 840 contour line, we know it has to be less than 840, but still has to be above 820 because it's within that circle. Okay, so next thing we need to talk about is where's the steepest part on this map? Which one of these lines, A, B, D, C, G, H, E, F, which one of those is the steepest? Tell me what you think. Okay, so what we're looking for is where the lines are closest together. And that's going to be GH right there. Those are our steepest lines because they are the closest together. The elevation is changing the quickest over the shortest distance. Okay, so we've talked about hills, elevation. We got to talk about these things called profiles. It's a look at the side of a whatever landscape you have. So if we're looking at the side of this hill, remember ovals and circles make hills. We're going from A towards the top of the hill, going from B towards the top of the hill. What's really important to notice is the lines are a little farther apart on the A side than the B side. So the A side, it's going to be increasing. This is going to be a look from the side. It's going to be increasing at a gentler slope than it is at B. It's going a little steeper at B because the lines are closer together. Therefore, our profile will look something like this, where it's a little steeper on the B side. Okay, next thing to do is to figure out a question like this. We are looking at the profile from X to Y, a look at what the landscape would look like from the side, from X to Y right here. Keep in mind that we have a stream right at C, this Rush Creek. So take a minute and think about, if you were to walk from point X to point Y, what would the landscape be like as you walk that way? Okay, so let's see how we did. Whenever you encounter a map, look at what it's giving you. We're given some contour line intervals here, or contour line numbers. We got 4,200 meters and a 4,000 meters. We got one line in between them. Therefore, this line is 4,100. We're increasing by or decreasing by 100 each line. So 4,200 to 4,100 to that 4,000 line. One more down is 3,900. So as you walk from X down to this river, we're starting at 4,000, going down to 3,900. Getting to the river, we cross that 3,900 line again, back up to the 4,000. So we are going from X down to the river, back up to Y. And the answer that reflects that is C, where we're going down from X, back up to Y. Okay, last thing I'm going to leave you with is rivers always flow downhill. Same picture we were just looking at. We got our elevations there. This river is going to flow from that 4,200 down towards the 4,000 and continue flowing downhill of that stream. What you need to keep in mind is maybe you aren't great at finding the contour interval. What you can look for in these maps is wherever contour lines cross a stream, they make a little point. These always point in the opposite direction the stream is moving. So I circled these 2 points. They're pointed to the down up at D, and kind of to down and to the left at A. We know our stream is flowing downhill from our contour lines, but to just prove it, the way the contour lines point is always going to be the opposite direction it is flowing. So that's all I have for you guys. Hope you have a really nice rest of your day.